Module 5, Lesson 5, titled The Area of Polygons Through Composition and Decomposition. The goal of this lesson, I can find the area of a region by composition and decomposition. As always, pause the video whenever you need to and make sure that you take good notes to follow along throughout. Now understand what we're going to be doing is finding the area of polygons that are irregular shape. They don't have a nice neat formula to them, but they still have an area because they still have space on the inside. We're going to find this area by composition and decomposition. What that means is we're going to be breaking the shapes apart into shapes that we do know, or we're going to add shapes on that we do know. Let's start out looking at the opening exercise. We have an aerial view of a woodlot. That means if we were in an airplane and we're flying over the top, we're looking down on a woodlot, it would have that shape right there. It has an area. We can figure that area out. But this first opening exercise is going to show us how we can find missing dimensions that we might need in order to find the area of this woodlot. They give us the information AB equals 10 units, so I'm going to label the line from corner A to corner B as 10. FE is 8 units, so from corner F to corner E is 8, right there. AF is 6, and DE is 7. And they want us to find the missing lengths of DC and BC. Now, in order to find those missing dimensions, what we have to do is we have to sort of imagine this as some kind of combination of shapes. So what I'm going to do is I'm going to I'm going to draw a line right there. That line doesn't really exist in the woodlot, but what that line does is it separates the woodlot into a rectangle A and a rectangle B. Then we're going to take what we know about rectangles to find those missing dimensions. We know that rectangles have opposite sides congruent. So I'm going to start with finding DC. Now DC is down here, this length from D to C. It is equal to this right here. Well, that doesn't have a dimension either. But notice that that line is part of this whole entire side of this top rectangle. And that's equivalent or equal to the side of the top of it. So the whole length down here from F all the way to this corner over here is 10. We know the total length. We also know the total, or from F to E is 8. Part of that from there to there is 8. To find this missing side here, we can take the total, 10, and subtract away the 8 and get 2. Whenever you know the whole length of a side and a part of it, you can subtract to find the missing part. Then, across from that, the rectangles are congruent so that we can see that DC is 2 units long. Now I'm going to erase some information here so it's not quite so jumbled up. Okay, now we have to find this BC over here. And if I put my line back right there, I can use that line up D7. There we go. If I look at the top rectangle that I've created, AF is going to be equal to the side from B to this line right here. So that length is 6. If I look at the bottom rectangle, DE is equal to the line where from C to the line that we drew, opposite sides. So that one is 7. Now I can find all the way from B to C by adding those two parts. If I want to know a total length of a line, and I know the two parts, I can add them together to get it. So 6 plus 7 gives me the total length of 13. Now the next part says they're giving us some different dimensions here, and they want us to find those missing dimensions. So let's go ahead and erase everything and start over again. And let's plug in the information that we're given this time. It says DC is 10 units, FE is 30, AF 28, and BC is 54. Squeeze that in there, 54. We need to find the lengths of AB, and we also need to find the lengths of DE. Let's start with AB. Once again, we can split this right there, and we would know that the opposite of DC down here is equal to that little line that we added on. That part is 10, and the part from F to E is 30. If we add those together, we get a total length of 40 down here at the bottom. And then opposite sides of the rectangle are congruent, so AB is going to equal 40 units. Now to find DE, these things here, DC was 54. I'm going to imagine a line right here this time. Oops, off a little bit. Imagine a line right here. Create two rectangles. BC is 54. It's going to equal the same as DE plus this extra part that we put right there. Now that extra part is going to equal 28 because it's the opposite of AF over here. I can find DE by subtracting. I know the whole entire side, and I know a part. To find the missing part, I can subtract. So I can take 54 minus 28, and that gives me a length of 26 units. So we're going to use opposite sides of rectangles. We're going to add parts to the rectangles in order to find those missing dimensions. One thing that I did not cover, and it's another option that we can do, is we can sort of extend this like that. That's another option that we have, and imagine this as one big rectangle, and that within another smaller rectangle. So, and then you can use those pieces of information about rectangles that you know in order to find that as well. If one method doesn't work, try others. Okay, try splitting it up in different ways in order to find the missing dimensions.